So in order to prove this theorem, the area of a sector of a circle of radius r is half into r square theta, where theta radians is the angle of the sector. Let us consider a circle of radius r and let this radius subtend an angle theta. Let us label this sector as OAB. Let us draw a line OC perpendicular to the line OA, and the angle of the sector OC is 90 degrees. So let us write this down. Angle AOB is equal to theta radians. Radius is equal to R. Radius OA is equal to R. Then we drew a line OC perpendicular to OA. Now we have an angle AOC which is equal to 90 degrees. First, to find out the area of this sector, let us find out the area of the bigger sector. So to find out the area of this bigger sector, we know that it has an angle of 90 degrees. So since the area of any given circle is pi r square, we know that a sector of 90 degrees divides a circle 4 times. So therefore, the area of the sector of this circle is 1/4 the area of the entire circle, that is pi r square. So let us write this down. For all, area of a circle is equal to pi r square. Therefore, area of sector AOC is equal to 1/4 the area of the entire circle, this pi r square. Because this sector AOC has an angle 90 degrees and 90 degrees divides the entire circle of 360 degrees into 4 equal parts. Therefore, it also divides the area of the circle into 4 equal parts. So, after that, we also know that area of a sector of a circle is proportional to its central subtended angle. So therefore, the area of this sector OAB is proportional to the angle AOB, which is theta. So let us write this down. Area of sector AOB is proportional to angle AOB, and also area of this sector AOC is proportional to the angle AOC, which is 90 degrees. Area of sector AOC is proportional to the angle AOC. Taking ratio of the above two equations, we get area of sector AOB divided by area of sector AOC, which is equal to angle AOB divided by angle AOC. So let us substitute the known values. That is area of sector AOB divided by area of the sector AOC, which is here 1/4 times pi r squared, which is equal to the angle AOB, which is theta radians. And angle AOC is 90 degrees, which can be converted into radians as pi by 2 radians. So when we cross multiply this equation, we get area of sector AOB into pi by 2, which is equal to theta into 1/4 of pi r square. Area of sector AOB is equal to theta into pi r square by 4 divided by pi by 2. Pi gets cancelled out and we get theta r square by 2, which is equal to half r square theta. So therefore, we have proved that area of sector AOB is equal to half r square theta, which where theta where theta is always in radians and it subtends the angle of the sector AOB. So where theta is always in radians and it is the angle it is the angle of the sector AOB. Hence, proof.